In this question, a scientist conducts two experiments using the same reaction and same conditions. But experiment 1 has a higher pressure of reactants than experiment 2. So we can see that in our image here. In experiment 1 versus experiment 2, we've got the same number of particles of each type, but in experiment 1, they're in a smaller volume, so they've got a higher pressure. However, we're told it's the same reaction and same conditions, so we're going to assume they have the same temperature. Our goal is to figure out in which experiment is the rate of reaction greater. So there are going to be three things that are going to affect our rate of reaction. Those are the frequency of collisions between the reactant particles. The more collisions we have, the more quickly the reaction can progress. The second thing is the average kinetic energy of the reactant particles. So when two particles collide, we need them to have enough energy to meet the activation energy for the reaction to take place. The higher the average kinetic energy of the particles, the more likely it is that the activation energy will be met and the reaction can take place. And average kinetic energy, that's to do with our temperature. That's the only thing that affects the average kinetic energy of our particles. So the higher the temperature, the higher the average kinetic energy. The third thing is the activation energy required. And the only thing that's going to affect our activation energy is whether or not we have a catalyst. A catalyst is something we can add to a reaction that provides an alternative route for the reaction to take place that has a lower activation energy. So that's what a catalyst does. Okay, so let's go ahead and think through for this example. So in which experiment is the frequency of collisions between reactant particles greater? So if we look at our images, we've got the same number of particles. However, in experiment 1, we've got a higher pressure and our particles are much closer together. So in experiment 1, our particles are more likely to be colliding with each other more frequently than in experiment 2 when they're more spread out. So I'm going to say in experiment 1, we have a higher frequency of collisions. Awesome. Next is asking about the average kinetic energy. Now we're told we've got the same conditions between experiment 1 and 2. So we've got the same temperature and therefore the same average kinetic energy of our reactant particles. So that's going to be equal for both. Next, for the activation energy, since it's the same reaction, the only thing that would change that is a catalyst. And we don't have a catalyst in either experiment 1 or experiment 2. So the activation energy is going to be the same for both. So finally, figuring out our rate of reaction. So let's think about our three factors. If we have a higher frequency of collisions, our reaction is going to happen at a higher rate. So the greater the frequency, the greater the rate of reaction. So in this experiment, frequency is higher for experiment 1. So that means our rate is going to be higher for experiment 1. And since our other two things are equal, they don't have an effect, that's going to be the overall effect on our reaction. So experiment 1 is going to have a greater rate. If our temperature and therefore kinetic energy was higher for 1, if we have a higher kinetic energy, that means it's easier to meet that minimum energy required, the activation energy, and so our rate is also going to increase. For the activation energy, the higher our activation energy, that actually makes it harder for the reaction to take place because we need our particles to have a greater kinetic energy in order for the activation energy to be met. So the higher the activation energy, the lower the rate of reaction. So in this question, since the only thing that changed was the frequency of collisions, that's how it affected our rate. But depending on what you have changing between the experiments, it might be the temperature, it might be a catalyst, that's going to change the rate of reaction in different ways. In this question, we again have two experiments with the same reaction and same conditions. The difference this time is that experiment 1 has a catalyst added. So let's go through again and look at our three factors and see how they're affected. So firstly, the frequency of the collisions. Now, we have exactly the same conditions other than the catalyst. So in experiment 1 and 2, the volume of our container is the same, the pressure of our particles is the same, the temperature of our particles is the same. So the frequency of collisions is going to be the same for both of those experiments. So that's not going to be a factor that affects us here. Nextly, the average kinetic energy. Remember, that's to do with temperature. Both of these experiments have the same conditions, including temperature. So the temperature is going to be the same for both. The kinetic energy of the particles is going to be the same for both. Lastly, for the activation energy. Remember, this has to do with a catalyst. Experiment 1 has a catalyst, and the catalyst lowers the activation energy. So experiment 1 is going to have a lower activation energy because of that catalyst, and therefore experiment 2 is going to have higher activation energy. So when we're asked in which experiment is the activation energy required greater, that's going to be experiment 2 because it doesn't have the catalyst. So in which experiment is the rate of reaction greater? Now, we said experiment 2 has a greater activation energy, but greater activation energy means a lower rate. So the experiment with the greater rate of reaction is going to be experiment 1, the one that has the catalyst and the lower activation energy. Let's do one last question of this type. In this one, we again have 2 experiments with the same reaction and same conditions, but in this one, experiment 1 has a higher temperature than experiment 2. So experiment 1, we can see, has a higher temperature, and experiment 2 has a lower temperature. So again, let's go through and think about our 3 factors. The first one is the frequency of the collisions. Now, we have the same concentration of particles. You can see they're spread out by the same amount in their containers with the same volume and the same number of particles. However, because experiment 1 has a higher temperature, those particles are moving around faster. So they're going to encounter each other more frequently simply because they're moving faster because they've got that higher temperature and higher average kinetic energy. So the frequency of collisions is going to be higher in experiment 1 because of that higher temperature. Now for the average kinetic energy. That is linked directly to the temperature. Having a higher temperature means you have a higher average kinetic energy. So that's going to be true in experiment 1. Lastly, the activation energy required for these 2 experiments is going to be the same because it's the same reaction and we don't have a catalyst in either experiment. And a catalyst is what lowers our activation energy. So we're going to have equal activation energy in both of our 2 experiments here. So overall, we've got a higher frequency of collisions and a higher average kinetic energy. And both of those things would cause the rate of reaction to increase because it means we're having more successful collisions. So the answer is going to be experiment 1.